So I have decided to start a new project because I haven't started enough already. And if you guys are a moderately long-time viewer, you would know way back in like late 2020 probably, I started this project. The Codex project is what it's called. If you go on articles, you can see these two Codex project files. This was basically going to be like a Python cryptography suite. So I started the concepts for it, right? Kind of talking about, I wanted to make like a Python shell script that could decode different ciphers. This was November 3rd, 2020, but I never really started it. So I figured, you know what, let's finally start it. This is the GitHub page for it. Again, it's a Python suite for cryptography. I wanted to be able to encrypt, decrypt, and brute force different like ciphers, texts, and files. I also want to have like one-liners implemented and stuff. All right, so let's check out the roadmap. The roadmap's going to be like the overview of the project going forward. This main ciphers I'm going to have is the Caesar cipher, Visionaire, multiplicative, reverse, and then base 64. Base 64 isn't a cipher, it's an encoding, but it still is pretty prominent within the cryptography world. Once we have these 5 ciphers done, that'll be kind of be considered like the version 1. These will be like just added on as the project goes on. I guess we can actually read the Caesar cipher one because that's the one we're going to be doing today. I have done Caesar cipher in Java and Python in the past. So I'm going to take my old code today and kind of reformat it so that way we can have it be more prominent to the Codex project, because it's an older piece of code. It's not that good. So I mean, it has the functionality we need. So I think I might just take this code and kind of just, you know, reformat it, I guess. Caesar cipher, I've covered this like twice in the past, 3 times probably. So I'm assuming you guys should be familiar with it. If you guys aren't, I'll just basically tell you, it's a cipher that shifts each letter within like a certain set of plain text by a certain amount. So if we have something like hello world, if we had a shift of 1, it would shift each of these letters 1 place down the alphabet. So H would be I because it's H-I, J, K, L, M, N, O, P or whatever. So F comes after E, so it would be shifted to F and etc. It's pretty simple. And you can shift it in between from, I guess technically an infinite amount of numbers, but there's only 26 possible placements, which makes it easy to brute force. If you guys are confused, just Google Caesar cipher or take my cryptography course, which is on my website. It's completely free. It just teaches you all the basics of cryptography and you get a certificate, so it's pretty cool. So I guess we actually need to get started with this whole thing. And because I want this to be like cross-platform, I want to add a shebang in here even though I'm on Windows. I guess this package needs to be able to be imported into our main file. So aside from all these folders, we're going to need a main.py, touch a main.py. And that main.py is going to be our actual Python file. So I guess we'll just see how much progress we can get done today, and yeah, we'll see where it goes from here. So I guess we should check out how this Caesar cipher works, or how we did it last time. So you can enter a file name, just already an encrypted Caesar.txt. You can do encrypt shift of 5. All right, cool. So the thing is with this, it only takes in file input. I want to have it where we can incorporate whether we want like file input or like a text input. So because this is a package, we need to have the main.py kind of take from the functions within this file. So how can we get, what's it called, argument parsing in Python? So we can print sys.arg v, and then we can do 0, and then print sys.arg v1. Python 3, or Caesar cipher.py, and we add like word after it, our argv1 is Caesar, or argv0 is the Caesar cipher file, and argv1 is word. Full credit to Neural 9, by the way. This is where I got these notes from. Now let's run this. Oh, we can just use a try and accept. So we'll try this, and if we get an index error, there's no argument. So print arguments. So this is what we're doing so far. All right. We're making, like, as you guys know, a cryptography suite. So we're going to have, it's going to be like a shell script. If you ever use like Metasploit or something, it's going to be like that, but for cryptography, right? So we're going to have the Caesar cipher, Visionaire, multiplicative, reverse, base 64, XOR, phonetic, binary, octal, hex, and Morse. Different ciphers like that. That's basically what this is going to be, right? Right now we're working on the CaesarCipher.py file, and this is the CaesarCipher.py is in the ciphers folder with an init.py file within it, which means it's a package, right? So what we're coding here is basically a Caesar cipher package that our main Codex file is going to use. Okay, right now we need to have our code to make it as easy for the user as possible, right? So I'm not only going to have one-liners, but we're also going to have a CLI, or a command line interface. And this command line interface is going to be something that the user can interact with. So again, when you're, interacting with the code, you can either do a one-liner, just have it be like, codex.py, tech, whatever, tech if for your input file, tech ot to have it be printed out on the terminal, and then like tech e to encrypt the file, and then tech k for your key. So you can just do that in one line, or you can interact with it, and it will ask you for your key, it will ask you for your file, that type of thing. So that's kind of what I'm doing right now. And we just got the argument parsing to work. Yeah, so if we just run the Python file as Caesar cipher tech.py, it's going to say false because we didn't add any arguments. If we do this and say hello, it's going to say true because we did add an argument to it. So that argument detection is going to allow us to detect whether or not they're going to be using one-liners. So if there is an argument, which is true, then we can just incorporate one-liners into whatever they're typing. Otherwise, we're just going to have it be like an interface that they can interact with, kind of like a Metasploit type deal. So hopefully that kind of clarifies what we're doing right now. Interesting. All right, what's up, people? Today we are going to keep working on this. I'm gonna go ahead and show my screen. So what did we do last time? Like, what was our error? So if we do a Python 3, I don't think our main.py is actually configured yet. Yeah, there's nothing in the main.py file. Python 3, and then our CaesarCipher.py. Okay, so what we need to do, and at least for most of this session, is we need to fix the keyword arguments and the CLI. Those are the two things we need to fix today. Okay, so why is this not working? I think it's the actual parser itself that's having issues. This is going to be like our help menu. And when someone just runs the file and wants to do one-liners, they need to know the arguments, right, in the order. File.py, there's going to be the cipher. So the cipher is going to be either tech E, D, or B, right? And then, yeah, so we're going to have the input, then we should have the output, then we'll have the key, and then finally, it's going to be the output. So when someone runs a one-liner, this is the format that it's going to have to be in. This is kind of dope. So what happens if we add something? Let's say if we add a tech E, cipher file reference before assignment. Cipher file is assigned here, and it's referenced here. So, oh, wait a second. Wait 1 second, y'all. Let me print the arguments, because it won't return an argument if we didn't put it in. Am I wrong in guessing that? But I think that's right. I think that's right. Okay, so let me actually run it instead of just like guessing or assuming. Key reference before assignment. What do you mean? Can I just do print parser in here? Can we print it out? Can we print it out? Can we get rid of this and just print it out? Oh my gosh. I make key a variable. It just has a value of none. Have you used argparse? Okay. No, I haven't used argparse. I probably should. But I'm figuring that, should I be using it? Because I'm just using, let me see if I can show you. Like, yeah, like, so this, like, kind of right here. So if you were able, like, if you ran like Python or like Python 3 file.py, the file.p would be the sys.argv0. Now, if you added something after that, like attack E or attack F, that would be system.argv1. You know what? All right, I'm going to take what you're saying into consideration. So I'm gonna just put, like, if this shit doesn't work out, use argparse. I'm gonna put that at the top right here. Notes, if this shit doesn't work, use argparse. There you go. Yeah, this function is really having the most problem. Oh, okay, wait. So if we do Python Caesar Cipher, tech E is the first one, then it's tech K, and let's just say 5. Input file. Okay, yeah, see, this is the problem right here. Okay, we're going to add a list, and we're just going to return the list of values that exist. Maybe do it with a dictionary. Okay. Well, I mean, if it's not working with a list, I don't know how sure I can be if it's working with the dictionary. All right, yeah, I'll try your idea. Fix me, I won't add all of the args. Why won't you? All right, let's see if we can try like attack F for file, attack T for tech, and attack O for output. All right, so let's see if we can run this. So attack K will be 5, attack, what is it, T will be hello. Yes, dude! Yes! You guys see that? I don't care that the encryption's not working. It got it. So I guess you can't have 2 letters, which is fine. Nums.get. Oh, I have square brackets in here. I can't have square brackets. So let's try this again. No way. No way. Y'all know how long that took? Oh my gosh. Look at that, boys. MJQQ. There you go. It works. The code works. Oh my goodness. Can we try doing attack F? And then we can do, what is it, file.txt? Okay. What's the problem here? Oh, it's getting the tac T. It needs to get the tac F. Look at that, dude. It's missing the exclamation point. Comment this out. And if we run this, there you go. Can we do attack O? And then, I don't know, output.txt. All right, moment of truth. Nope. So if it's attack O, we just need to fix this, attack O. Let's try this again. There's an output.txt. Yes, dude. Oh my gosh. Now that I'm thinking about it, do I want to add a CLI? I feel like the extra functionality would be helpful for people. If I can't get the CLI to work, I don't think I'm gonna implement it, because we have one-liners working perfectly now. because we had to ask them for all the inputs manually, because then it's just more complicated. So if there aren't any arguments, we can just have the help menu show up. I'm really thinking this is a better idea, because if someone doesn't specify the arguments, then we can just show the help menu of the arguments that they have available to them. I feel like that's better, and I feel like that's what most shell scripts are doing. But then again, I don't know. How can we get a good CLI that doesn't keep asking for a shit ton of user input? Yeah, alright, that's what I'm gonna do. Alright guys, say goodbye to the CLI for now. In the future, I might implement it, but at the end of the day, I'm figuring that the one-liners are a lot more simple and a lot more straightforward. All right, so the encryption process works. So now we had to develop the decryption process. So now instead of adding these, all this is going to do is subtract these. And then we're going to say decrypted content. So with the decrypted now done, we should be able to change this tag E into a tag D, and then change world into an NFICU, and the output should be the word world. Yes, dude, look at that. We decrypted it. World, so we were able to encrypt it and decrypt it. Hey hackers, time for another stream. So I honestly don't remember where we left off last time with this whole thing of creating this project. So I guess we're just going to jump into it. What's next? Brute forcing, that's right, okay. And now we're going to have our brute forcing function. So def brute force. How do we actually get this brute forcing process step? Now when I first developed the Caesar Cipher, I developed a process where you could either brute force the Caesar Cipher with a range or brute force the Caesar Cipher standalone. So let's see if I can implement this old version back into this new version. So we can do what tech R, which is our range. So we can just say start, end, and then choose a range of keys to start and end the brute force. If the range is true, we're going to have a range 0 for the start range, and then a range with the value of 1 for the end range. So a start range is going to be equal to 0, and our end range is going to be equal to 27. There you go. So now all we have to do is actually perform the brute forcing process. Cool. So I'm gonna just take this old version right here. Cool. So we're going to paste in here and we're going to start modifying this. I guess we can test it and see if it's working. And oh, there you go. So number 5 is hello, because that's the encryption. Look at that, dude. Oh, that is awesome. I'll zoom in for you guys. So what this did is that we brute forced it, right, with the shift key of 0, then a 1, 2, all the way until 26, right? And that's the standard version. Because the shift key used to encrypt that text is the number 5, we got our hello in that brute force. Technically, the range should be working. So Caesar Cipher, tag B, which is for brute force, tag T, which is the text. And then if we do a tag R for a range, and if we just do a range of 1 to 10. Okay, so that didn't work. Well, we can just shift tab this over, comment this out, and there you go. So let's try this again. String cannot be interpreted as an integer. Oh, we're just going to make this an int. Oh, okay. I was wondering what was wrong. Int, run this. Yeah, there you go. Okay, so all we have to do is add 1 to the second value. So we can just do a +1. And hopefully that, there you go. So it does 1 through 10. Awesome. So I think we're pretty much done with the Caesar Cipher parts. and I need to figure out how we can actually start developing the actual main.py, which is empty, which is kind of sad, but you know. So hypothetically speaking, what I want this to be able to do is, right, so I want to be able to run this main file and then with a one-liner specify whether I want to use the Caesar Cipher or, I don't know, Visionaire Cipher, and then from there I will be able to run whatever cipher I want to. There you go. I'm bad at talking. Your vid on Monday was awesome. Loving your content. Thank you. Yeah, the vid on Monday, I think that was like the 4th version of that payload. It took me a while to build that thing, but it was actually a lot of fun to do. But yeah, I'm glad you enjoyed the payload. Some of you guys were asking some more like advanced topics or advanced payloads, so I was like, well, cool. Because a lot of my background, if you saw the Hack5 interview, is malware development. And I also like web hacking, cryptography, things like that. But with malware development and Hack5 tools kind of go hand in hand a little bit. So it's definitely a fun toy for a guy like me to use. So from ciphers, we're importing all, right? So we go to our ciphers directory, right? And we're getting our Caesar cipher.py. Okay, instead of importing all, let's just import our Caesar cipher. Whoops, Caesar. I cannot spell Caesar Cipher. There you go. Okay, so that seems like it's gonna work. Python 3 main.py. Oh, let's go. There you go. Okay, so we can actually run our Caesar Cipher. So we're checking for arguments. That's all we're doing. If arguments exist, then it will be true. If arguments don't exist, it will be false. So we're running CLI, which is the command line interface. Cool. I guess we actually do need a CLI function in here. So now this is where we actually start getting the arguments, right? All right, we're almost done with this part. So now we have the Caesar argument that verifies that we actually are using the Caesar. So now all we have to do, hopefully, is just to try. Oh, wait a second. We may not need a parser. So the 0th one's going to be the file name. The first one is going to be the ciphering option. So the second argument is going to be the ciphering process. So os.system. So remaining arguments is equal to sys.argv. And then, so what's the second argument? And then pass everything from the second argument to the end. Oh, so can we just do, why is that not working? Because these are the other arguments. Let's print out whatever argument it's getting. Let's print these out. Oh, it's taking it as a list, I guess? Instead of os.system, let's print this. What does this look like when it's going through the terminal? See, that's the problem. We need to turn this into a string, comma, and then all we have to do is put the remaining arguments. So like that. Yeah, so instead of comma, let's put a space, and then there you go. Okay, wait. So if we os.system this instead of printing it, delete this, and then os.system. All right, moment of truth. Claps in the chat, people. Claps in the chat. I don't know why this part is erroring, but right down here, MJQQT. We encrypted it. There you go. Okay. Now we need to figure out why this no value was given thing is here, but it worked. Oh, it's because we have the parser up here. All right, we don't actually need the parser anymore, so we can actually delete this. So if we run this again, there you go. It works. It works. All right, so now all we have to do is to specify it. Oh no, when we're doing that, it actually may not work. Now that I think about it. Oh no, it works. Okay. All right. So let's actually check it out. We can do a Control L. So if we do a Python 3 main.py, it says it gives you the help menu. All right. And if we look at this, or like, so we can actually do our main.py, and then, all right, let's do a Caesar cipher with the tag T, or the tag C. So we can do a tag C, and then we can do a tag E to encrypt, a tag T for some text. We'll do hello, and then a tag K, which will be, I don't know, 15. And then we got the encrypted version of hello. Look at that. Look at that. Yeah, there you go. All right, so you guys have the most updated version of the code. All right, so that's it, guys. All we need to start doing is adding newer and more ciphers. So now that we have this base version done, everything from here on out should be really easy. All right, guys, so in this stream, we started from a working, or we fully developed a working Caesar Cipher Python package, and then we also were able to implement it into the main.py. So we got the whole thing working, we added brute forcing. Now all we have to do is start adding these new ciphers. So next up is going to be Visionaire cipher, then we can do, I don't know, multiplicative reverse ciphers, or all these cool ciphers, and we can just keep adding it and importing it, and you guys can keep using it. It's not done, obviously, but it is working. It's not pretty, but it's working. So if you guys want to check out the current version of it right now, I'll have the link in the description. It's pinned in the chat and everything else. But that's going to be it, guys. I think this was a moderately entertaining stream. Hopefully you guys enjoyed. Dig talking to you guys, and yeah, I will see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.